Hello everyone. I hope you are doing well and fit and fine. This is today's problem. This problem is interesting. Gonna solve next greater element in circular array. If you have not solved next greater element, don't worry. We'll cover that as well. Cover the complete idea of the next greater element. This is a very important idea in the monotonic stack framework, and it's been used at most in many very good problems, so you should know about that. So yeah, if you're new to the channel, make sure you hit the subscribe button and like the video because we make awesome content around tech, DSA, and AI. Okay, before starting of the video, let's try to understand what problem is saying. Next greater element. Okay, given a circular integer array, the task is to determine the next greater element for each element in the array. The next greater element of an element is arr of I, is the first element that is the greater than arr of I while traversing circularly. If no such element exists, return -1 for that position. Okay, since the array is circular after reaching the last element, search continues beginning until we have looked the all element at once. Basically, it's saying is it's like connecting like this: 1, 3, 2, and 4. 4. Okay, it's like this. So it could happen that 1, 3, 2, 2. You will say that there is no next greater element for 2 because it's on the rightmost side, but no, it's not the case. 3 is the next most greater element, right? Because it will, if you cover it circularly, it will be 3. So before covering to this problem, let's try to quickly cover the next greater element idea. Then we'll come to this problem. This is a slight variation of that problem. Quickly, let's try to do that first. Next greater element. Forget about the circular array. We'll firstly see this next greater element. What is the prime idea? We created a vector of the next element. Okay, for each index, we'll create the next. Okay, fine. How will we do that? Let's say we have 3, 2, 5, 4, 7, 2, 9. Okay, this kind of array we have 3, 2, 5, 4, 7, 2, 9, and we want to return the next data element to corresponding to each index. Fine. How would you do it efficiently? One way is very simple, the O of n square solution. What are you gonna do? You're gonna start it from the iter or the ith index. Look for that who is the element who is the next greater to that, and it's done, right? For 9, there won't be any. For 2, it will be 9. For 7, it would be 9. You will gonna be searching. Then for 4, it would be 7. For 5, it's gonna be 7. For 2, it's gonna be 5. And 3, it's gonna be 5. So this is how something is happening, and you will be iterating that. The worst case of this solution would be n square because you may end up getting last value, right? You can go, let's say you don't find anything, that's also a case at 1 1 1 1 1 1, right? There's no next greater element, but you have to iterate for all the elements. So worst case complexity of n square. I hope you understand it. But now let's try to understand how we can determine the next greater element corresponding to correct index efficiently. So what is the prime idea? Do you tell me that? Let me just draw with the help of bars. This will, you will understand this problem better. Bigger bar. Let's say 9 is this, 2 is slightly this, 7 is slightly this, 4 is more than that, 5 is slightly more than that, 2 is almost similar to that, and 3 is slightly bigger than that. Okay, this is the bars. And now you need to calculate the next greater. So you tell me for this, what is the next greater element? This is fine. For this is the next greater element. And for this, if you know the next greater element, like, can you this be the next greater? No, right? You cannot see beyond this. So if you know somehow this, what is the largest coming on that side, you don't need not to check these elements, right? Need not to check these elements. These are already out of case. You can say that for this, if you come to here, then what are you gonna do? Oh, for this you already computed this, so you just need to check quickly this, or maybe this, right? You don't need to check the last ones because they're already out of the case, because we already removed them. Because for this should be greater, right? So for this, you check, oh, either the next element or whatever we have computed previously. That could be one of the possible. answer, right? In a certain way, we are actually rejecting some of the tokens, or you can say from the right hand side, from the right hand side. So, what data structure would you think this will be helpful in this case? That trying to, we are what we are essentially doing. We are focusing on, okay, we have computed something, we come along some way. We are definitely sure that this gonna be the answer or nothing will be the answer. Somehow we are trying to imply that thing. Okay, okay. That means what? Okay. Let's try to understand with some trivial cases. For nine, to obviously there is no next grade element. For let's say the nine, the answer is -1. Okay. Now what I'm trying to say is what you will check. You will check from the topmost side, right? Because you will check the immediate next. Immediate next. So when you are I will be traversing from right because we have to calculate the next crater, right? So we cannot traverse from left, you have to traverse from right for calculating the next crater. Okay. Now the basic idea is you go from the right to left, you find an element, okay? You find an element. Now what you're gonna do is it's like a wall for you. Now you have to we have to just check the immediate thing. Immediate thing is something like last in first out. This is a simple intuition that what I'm trying to say is you're focusing on the last element inserted first, right? Whatever previously, and it would be more priority. We'll check that first. If that is satisfying, then it's no problem, right? So that means okay, this we get the idea, and from here directly we get the idea of so what our algorithm says is it's pretty simple. It's not very difficult to understand that okay, what do you wanna do? Let's try to push nine. Let's try to go and push nine to a array. Okay. Until we find a topmost element. From nine, there is no topmost element. Okay, fine. Now we went to two. Okay. Now we will ask, oh, if there are any smaller elements, like if there been some smaller elements that less than two, then they're of no use to these elements, right? If they're smaller than 2 itself, then 2 will be the answer, right? For the answer, if they are previous, let's say this is 1, 1, 1, 1, 1, 2, and this, let's say 1, 1. So is these ones are useful to them? No, 2 will be the answer, right? Because 2 is larger than them. So you will remove these 2 and they will reduce the search phase for these elements. That's our prime idea. Okay, cool. That means, okay, so we push the 9. Okay. When we come to 2, we'll check. Oh, 2 is the st dot top is greater than, like, we will remove until s dot top is smaller than our current num. So, okay. So we'll keep removing that because these are useless things, right? Same thing what we are doing initially as well, that we are iterating, but now we are actually efficiently iterating, removing the cases for the next element, sort of. Okay. Okay, we are removing them. So, oh, it's not the case. So, okay, no problem. Now, what you will do, will keep push the current element as well. So, you found the answer for 2, it's 9 itself. So for 2, you found the answer 9. Okay, you went to 7. Then you will check, oh, the next element. From the top, you will start checking. Oh, no, 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 it's not larger. So you have to pop it out. Because now 2 cannot be the answer. Because 7 would be the first preference, right? Why 2 will be the answer for the next greater element. Now 7 is more closer to the left elements, right? So 7 is the answer, or nothing will be the answer, right? Or maybe the 7's next to be the answer. So 2 to definitely won't be answer because 7 is 2 is less than 7 itself. Okay, 9, oh, 9 is there. So you will find, say that 7 next greater is 9 and you will push 7 inside that. Cool. Then you're gonna do the same thing. Oh, you will check. Oh, 4 is greater, no problem. Just push 4 and 4 is next element is 7 directly, right? This is how efficiently you are checking because you are betting on this. 7 thing is very, very important. Now for 5, let's say for 5 we go. For 5, 4 is not required because there won't be an answer. Let's put 5 and then for 5 it would be 7 again. For 2, what do you, no problem. 2 would be the answer for 5 itself. The next only. Then for 3, oh 3, 2 wanna going to be answer, 3 wanna be answer. 3 will be the value of 5. Right. So this is how efficiently you calculated it. Now let's try to understand in the worst case scenario what would happen. It would be like 1, 1, 1, 1. What gonna be happen? So you're starting with 1. There's no next greater element. Cool. No problem. Okay. No problem. Then you come to this. You will keep checking. Oh, is there any next greater element? No. So the stack will be empty. Will stop. You will stop. You will wait. Stop that. Oh, there's no element. That means it has again minus 1. Answer is minus 1. Again minus 1. Then you're gonna check. Oh, stack is empty. Again minus 1. Oh, stack is empty. Again minus 1. It's seeing we are not checking all the elements now because we are optimizing our search space using this while loop. Right. This is our prime idea. After that, you'll push the current element of the stack as well. Oh, sorry, here you will push one element and then you gonna again pop it out because it's not greater. If it is exactly same also, then also we will remove it. Why? Because this is not greater. That we want a strictly greater condition. So each element we're just pushing and popping. That's all is happening. So in a way, what do you think the time complexity of the solution is? The time complexity of the solution is just O of 2n. We are just iterating it once and just putting it once back out. So you can say sort of reversing and back to and fro motion of during this while loop also inside a for loop. Then it will be of 2n, right? So this is a pretty straightforward problem. Let's try to see now this problem. Can you solve this problem now? Now, what is the idea problem is? Yeah, now you cannot say the last element answer is minus one. You cannot say that. Why? Because it's a circular array as well. So what's the trick? It's very simple, yeah. Just replicate this array. It's very simple. 2n times. It's like 1, 3, 2, 2. Simple. Right. Now its problem becomes very simple. For this answer, you use minus one. Now you apply the same logic for your whatever this. For this answer is minus one. For this answer is minus one. For this answer is 3. For this, now answer becomes 3. Right. So just replicate the current array. It's very simple. Very simple. You don't need to actually replicate the array as well. You can just iterate 2n times and you can use indexing logic. Let me just show you. So what you gonna do? It's very simple, yeah. You initialize the next vector for calculating the answer for n. Okay, you initialize our stack. Then what do you want to do? Since I already told you, you have to go just replicate the array twice. Just 2n minus 1, I greater than equals to 0, I minus minus. You find the index because you have to do a modulo, right? Corresponding to that. Okay, for this, what will be the answer? So you're gonna be doing a modulo with n, and then what you gonna do? We will keep checking. Firstly, it should not be empty. You'll keep checking. We're storing here index. You can directly put the elements as well. There's no problem. And in that as well, ER or stop until they are smaller. Like the top elements are smaller than our current index or equal also. We'll keep popping it out, keep popping it out, keep popping it out. And then what we do, we only push into our, you can say that next of index when I should be less than n, right? Because for these, we don't need to do that. These, no answer is required. Only for these elements we require the answer. So just a modification. We just check this condition. Okay, if I is less than n, then and also one more condition we'll check, stack should not be empty. If stack is empty, already minus one, we already populated it. So no problem with that. What we're gonna do, arr of st dot top. It's very simple. And then we push the index. Every time we pop it out, after performing each operation, you push this current because this could be the answer for the previous guys as well, right? That's why I push this and we just return the next. So I hope you get the gist of the idea how simply we use the standard problem. This is a very standard problem and use the standard idea, just a small tweak that this is how interview questions and online assessment question works, right? You given a standard problem, just they tweak it a little bit. You how you think, that's your challenge. So I hope you understood the solution. If you understood the solution, make sure to subscribe to the channel and make sure to like to the channel a video. So we'll see in the next video with a more awesome content, right? Okay, guys. Bye bye.